Hello and welcome to our first lesson of the last chapter for first semester. We're going to look at chapter 10, go through the first 4 sections, and then take our last test and start reviewing for finals. Section 1 is going to deal with organizing and displaying data. We'll start off with how to take fractions and turn them into percents. And basically what we're going to do is use our calculator, and I suggest you get a calculator for this lesson. And we're simply going to do the division, get a decimal form, and then move the decimal 2 places over or multiply by 100 and then put a percent symbol on the end. So when we use our calculator here for 4/16, you would get 0.25. Moving the decimal 2 places over, our answer is 25%. Throughout this lesson, I'm going to ask you to see if you can do some of the problems on your own, and you'll hit pause and give it a try, and then you can hit the play button and see how things went. So for number 2, why don't you try to do that, turn that into a percent. Okay, when I did the math on this, I got 0.2, and of course, I need to fill in a 0 there to call it a percent of 20%. Number 3, give that one a try. I got a 0.125, which causes me to move my decimal 2 places over, and I still have a 0.5% on the end there. And so you'll want to occasionally need to use decimals even in percents. These last 3 questions, it's how we take the percent and then apply it to a larger value. A typical application might be if something's on sale and they're saying there's a percentage off, you pick out an item, you want to know how many dollars you get to save, or maybe more importantly, how many dollars you have to spend to buy it. So for these, when we multiply the percent times the total, we're going to have to first now convert it back to a decimal and then multiply. So 20% is a 0.2 times 360 is 72. Likewise, 0.75 times 360, go ahead and try that on your own. Okay, I got 270. This last one, I'll give you a hint. Think of 360 as a fraction, 360 over 1. And then when you multiply, you just multiply across top and bottom. See what you get for that one. All right. 360 times 1 is 360 divided by 15 times 1, which is 15. Do that division, you get 24. Okay. This entire section will cover these objectives. Today we're really only going to do the first objective, review how to read different types of graphs. Our vocabulary will be throughout the lesson, so keep that ready, and as you come up on a definition for these terms, get ready to flip back and fill in the blanks. Bar graphs, line graphs, and circle graphs can be used to present data in a visual way. A bar graph, and this is a definition I'd like you to put in your notes here, a bar graph displays data with vertical or horizontal bars. Bar graphs are a good way to display data that can be organized into categories. Using a bar graph, you can quickly compare the categories. And this comes up when you have to make comparisons that are offsetting. You have to choose one or the other maybe. For example, use the graph to answer each question. Which casserole, or as we say in Minnesota, which hot dish, was ordered the most? And we just look at the length of the bars and see that it was lasagna. About how many total orders were placed. And if we want to figure that out, we're just going to use our scale here. It looks like this would be 60. So the total values that we'd have would be 60 plus roughly 25. Just under 20, I'll call it 18 for the ziti. And the King Ranch casserole or hot dish, we'll call that 32 maybe. And then the tuna noodle, we'll call 42. And when I get my calculator out for that, I see 177. About how many more tuna noodle casseroles were ordered than King Ranch? Well, this is just going to be finding a difference. And the tuna noodle we estimated at 42, and the King Ranch estimated at 32, so say roughly 10. About what percent of the total orders were for baked ZD? And here we're going to want to look at a ratio. We know our total, and out of that the baked ZD represented the smallest number, the 18. So as a percent we can do 18 divided by 177. About 10%. Another graph with ingredients and determining how they compare in terms of fat, which ingredient contains the least amount of fat. We'd look for the shortest bar here, and we'd see that it's bread. Which ingredients contain at least 8 grams? We'd find 8 and look at all values that are to the right of that. It looks like cheese and mayonnaise. A double bar graph can be used to compare two data sets. A double bar graph has to have this key so that we know which data set we're comparing here. So if we look at two sport utility vehicles, SUVs, and want to compare 5 different categories, which feature received the same satisfaction rating for each SUV? And there we're going to look for where the bars are at the same height. And it looks like the cargo space. Likewise, which SUV received a better rating for mileage? And that's going to be an issue for people. We want the highest bar, and we go to the mileage, the far end here, and it was the blue one, SUV Y. I do another example here. I'm going to ask you to hit pause and see if you can answer the question on your own, and then hit play and see how things went. All right. Well, in order to find which years basketball had the same, we've got 2 sports being listed here, football and basketball. We want to look at where the orange bars are roughly the same in height, and that looks like in 2001 and 2002. Overall, there's a bit of a trend we could notice too, just to point out. Looks like basketball attendance was going up fairly steadily till about 03 and then hit a dip there in 04. Football likewise was following a similar pattern. What was the average attendance for those years? Well, somewhere between 10 and 15,000. We would probably call that 12 to 13. I'll call it 12,500. A line graph, different type of graph now, displays data using line segments. Line graphs are a good way to display data that changes over a period of time. We can see by the slope roughly whether things are increasing or decreasing more or less rapidly. All right, we're going to use this graph here to answer each question. At what time was the humidity the lowest? And if you look at the graph and look at the dot, it looks like at about 4 a.m. During which 4-hour time period did the humidity increase the most? And this is going to be between which period, so we want to see the steepest slope, and it looks like roughly the same from 8 to 12 or 12 to 4. Okay. Once you try this example, read the question, hit pause, and see how things go. All right, coming back, use the graph to estimate the difference in temperature between 4 and noon. We're going to say the difference, well, at 4, it started at roughly 62 degrees. And then by noon, that was pretty easy to read, it was 80 degrees. So 80 minus 12, 18 degrees different. A double line graph can be used to compare how 2 related data sets change over time. A double line graph has a key to distinguish between the 2 sets. This is similar to that double bar graph. In which month did Station A charge more than Station B? We look and see that the red is Station A and then the blue is Station B. So Station A had charged more not until, looks like April they were the same, so May and back to about the same in June, July, but it looks like May only. And during which months did the stations charge the same for gasoline? And here, to charge the same, we're looking at where the data points are overlapping. We talked about that a little bit. Looks like April, and again in July. All right, a circle graph. Our last graph shows parts of a whole. The entire circle represents 100% of the data, and each sector represents a percent of the total. Circle graphs are good for comparing each category of data to the whole set. So put this in your definition. There's a definition within this called sector. Notice that. That's what the wedges or pieces of the pie are going to be called. All right. Use the graph to answer the question. Well, we've got percents written here. It says which ingredients are present in equal amounts. By shape, we know that the ginger ale and the orange juice are higher use, but the lemon sherbet and the pineapple juice have similar sizes, and sure enough, when we check their percents, they're identical. So we would say that the lemon sherbet and the pineapple juice Once you try this one on your own, read it and hit pause, see how this goes. I'll give you a hint. To find the percent of the fruit salad that is cantaloupe, you're going to want to know the total amount of ingredients and compare that to the amount of ingredients, amount of cantaloupe used. Okay, I've got my calculator out. I'm going to add up all these values. I'm going to use decimal form. You probably do as well. I'm going to do 0.5 plus 3.5 plus 1 plus 2 plus 3. I get a total of 10. The total volume is going to be 10 cups. And of those, the cantaloupe represents 3.5. So I'm going to have 3.5 over 10. Really don't need a calculator for this. Looks like it's going to be 35%. And now that we've gotten through the entire lesson, let's go ahead and take a quiz here. Just 2 quick questions, see how that goes. Hit pause, and then when you're done, you can hit play and see how things went. Okay, just 2 quick questions here. First one, which 2 apartments are about the same size? And we're looking at a bar chart that shows area, and we're looking for lengths to be the same. And they're all fairly similar, I guess. It's obvious which one's the smallest and which one's the largest, but it looks like these 2, the Candle Run and the Lamar Place, are the same in size. Question 2, price of strawberries. In which weeks did store B charge more than store A? We're looking for where the graph of store B's prices is higher. And in this case, there are 2 situations where store B is the same, quite a run there where store B is cheaper, but only in the first period from week 1 to week 2 is store B more expensive. All right, we'll look forward to seeing you in class. You can get started on the homework here and come with your questions.